In this question, we want to determine whether the following system of equations is consistent or inconsistent, and we've got three planes. Well, the first thing we do is check to see whether any of the planes are parallel, and we do that by checking the normals. It turns out none of these are parallel. So what that means is that we either have one point of intersection, or we have a line of intersection, or we have three planes that don't intersect, form an inconsistent system by forming a triangular prism. So the only way to tell is by setting up a matrix and doing our matrix work. So let's multiply the first row by 2 and each of the next rows by 3, and we get this here. We can now, into our next matrix, multiply this by a half again, get it back to 3, -1, 4, -8, just to keep the numbers small. But also, before we do that, determine row 1 minus row 2 and row 1 minus row 3, thereby eliminating the x's. And we've done that. At this point, we then multiply the first row by the second row by 17 over 5. In other words, we recognize that this is really 0, -5, 5, 5 is the same as 0, -1, 1, 1. And once we have it there, we can multiply by 17 to get it to where we have the two y entries the same. Once we do that, we can subtract row 2 minus row 3, and we get this as our resulting matrix. Once we do that, we see we have one and only one point of intersection. And it's relatively easy to solve. 3z equals 6, which means z equals 2. Subbing that up into the second row means y equals 1, and subbing both of those values into the first row means x equals -5. And so we see that we have one point of intersection, specifically at -5, 1, 2.